All right, so we're always talking about the Kubernetes control plane as the brain of the whole operation, right? But think about it. What good is a brain without any memory? So where does Kubernetes actually keep all of its crucial memory?
I mean, seriously, just picture it. You've got this massive system, juggling thousands of containers, maybe across hundreds of different machines. It can't just be winging it, you know? It has to have a reliable, long-term memory to keep track of everything. So the big question is, where is that memory?
Well, if we're going to stick with this brain analogy, then what we're really looking for is the cluster's hippocampus. That's the part of the brain that's responsible for all the long-term storage.
And guess what? That hippocampus has a name. It's called etcd. Now, on the surface, it's a pretty simple thing. It's what we call a key value store. Think of it like a super basic dictionary. But its role? Oh, its role is absolutely monumental. It is the one, single, solitary source of truth for everything happening inside your cluster. And I mean everything. If you lose etcd, your cluster basically gets total amnesia. It's lights out.
So what kind of memories are we talking about here? Well, it's basically the entire blueprint for your whole cluster. It knows all the high-level stuff, like your deployments and your namespaces, but it also knows all the nitty-gritty details, every single pod, every secret, the health status of every single node. And here's the really important part. It stores two key things. First, the desired state. That's what you want the cluster to look like. And second, the current state. That's what it actually looks like right now.
And that right there is the whole ballgame. See, in a super complex distributed system like Kubernetes, you just can't have different parts of the system working off different information. You can't have multiple sources of truth. That's a recipe for absolute chaos. You need one and only one to bring order to the whole thing.
Yeah, and this slide just lays it all out perfectly. Imagine a world without that central truth. You'd have the scheduler thinking one thing, the controller manager thinking another. It would be a total mess. We're talking data corruption, conflicting states, a system that's just constantly falling over. But with etcd in the middle, you get beautiful order. All the data is synchronized, consistency is totally guaranteed, and the whole system just works. It's stable and it's highly available.
So how does it pull this off? Well, the secret sauce is this really cool technology called the Raft Consensus Protocol. The easiest way to think about it is like a little election. Before any change is made permanent, all the ECT nodes have to vote and agree on it. They have to reach a consensus. And this whole process is ridiculously fast. We're talking microseconds. Plus, since ECT runs as its own little cluster, if one node goes down, it's no big deal. The others just keep on chugging. No single point of failure.
Okay. Enough theory, right? That's all great, but let's see how this actually works in the real world. We're going to follow one simple little command and trace its journey from start to finish. And you'll see just how etcd sits right in the middle of everything.
Let's say you type in a classic command, kubectl/scale/replicas equals 5. Okay, what happens next? Step 1, your command hits the API server. And the very first thing the API server does, boom, it writes that new desired state, 5 replicas, into etcd. Now, the controller manager, which is basically just watching etcd all day long, suddenly sees a mismatch. It's like, whoa, hold on. The plan says we need 5 replicas, but I'm only seeing 3 running. So it tells the scheduler, hey, find me some space for 2 new pods. The scheduler does its thing, finds the nodes, and then the kubelets on those nodes actually spin up the new pods. And then, and this is the key to closing the loop, the kubelets report back, job's done, and update the current state in etcd to 5. See that? Nobody talks to each other directly. They all just talk to etcd.
Okay, so this brings us to a really, really important point. We keep saying etcd stores everything, but what does that everything actually look like? And maybe more importantly, what are the security implications of having all that information in one place?
Well, here you go. This is it. This is what the memory for a single pod actually looks like inside etcd. It's not magic, it's just text. It's a simple JSON object that describes what the pod is supposed to be and what its current status is. That's it. And every single thing in your cluster, whether it's a service, a deployment, or even a secret, has an entry that looks pretty much just like this.
But let's be super clear about something. etcd is a specialist. It is not a regular database for you to use. It doesn't store your application's data. It doesn't store user data. It doesn't store logs or metrics or any big data sets. Its one and only job is to store the configuration and state of the Kubernetes cluster itself. That's it. Full stop.
And because it stores the really sensitive stuff,
We're talking your secrets, your database passwords, your API keys, all the crown jewels. It has to be locked down like Fort Knox. The data is always encrypted when it's just sitting there, what we call at rest. All the communication back and forth is secured with TLS, and in any properly set up cluster, the only thing that should ever be allowed to talk to etcd is the API server. Letting anything else talk to it directly is a huge, massive security risk.
Whew. Okay, I know that was a lot of technical detail. So to wrap this all up and make it stick, let's use one last analogy. I want you to picture your Kubernetes cluster as a gigantic, super busy hotel.
So, in our hotel, etcd is the master booking register. You know, that big old-fashioned book that knows the status of every single room? The API server, that's the reception desk. It's where all the guests or requests come in. The controller manager is like the head of housekeeping, always walking around making sure every room is in the state it's supposed to be in. The scheduler is the person who decides which room each guest gets, and the kubelets, they're the hotel staff, the ones who actually go and clean the rooms or deliver room service. And notice, every single one of them, from the front desk to the cleaning crew, they all look at that one central booking register to figure out what they need to do next.
And so that brings us to the final and most important question of all. What happens if you lose the hotel's booking register? Well, the whole place descends into absolute chaos, right? The staff has no idea which rooms are clean, the reception desk doesn't know who's checked in or out, the entire operation just grinds to a halt. And that right there is why ECD is the quiet, often forgotten, but absolutely vital heart of every single Kubernetes cluster in the world.